Hey guys, welcome back to Hayley Tries to discuss math topics that she knows very little about without her notes. Today I'm going to be talking about logarithmic functions. My notes are over there. I wasn't looking at them over here. I should probably close the note page because I am attempting to quiz myself as I have a math test today. Yay! So, logs. They are the inverse of 10 to the x, which is an exponential function. So, what I mean by inverse is that the x and y values are swapped. So if you had a point 34, then the inverse point would be 4,3. It's written as f to the x into, so that's like a little arrow, f negative 1 to the x. F to the negative x is entirely different. That means that it's flipped on the y-axis? Yeah, on the x equals 0 axis. Cool. What else do you need to know about this? Not much. So it's written as f to the x because I'm doing the IB program and they don't want to just say y. No, that would be ridiculous. So the function at x equals a times log b. So log is typically assumed to be just log 10, which means the number, or 10 to what power equals a number. But you can have other numbers as well. So on your calculator, I have my graphing calculator right here. If you just hit the log button, on mine, it's right beside the 7. It'll say log and then like a little bracket. So inside the bracket, you can type in a number, say 100, and then you hit enter. And it gives you the power to which 10 equals the number that you typed in. So in this case it's 2. 10 squared is 100. If you're looking to do a log with a different base, on my calculator, you hit the math button. It's right underneath the alpha key. And then you go all the way down to A, where it says log base and then another little bracket. And you hit enter. So it'll have a little blinky light that's in a subscript to log. Quick little note here. Subscript is like, here's the word, here's the number, whereas superscript is here's the word, here's the number. So subscript is below and sorted to the side, and superscript is above and sorted to the side. Anyways, so it'll have a blinking subscript, and you can type in whatever number you want. For example, 2. So log base 2, so 2 to what power gives you, and then there's another blinking light inside of a set of brackets. So say I wanted to find the log base 2 of 72. Now, there's no way that this is going to turn out like as a whole number, as an integer. There is going to be decimal places because it just doesn't work out well. There's no number that you can raise 2 to that will give you 72 evenly. So the answer ends up being 6.169925001. The reason why logs are great is because there is no way that I would have had the time to trial and error to find out 2 to what power equals 72. That would take ages to find exactly the right number of decimal places to give me 72. There would always be something that's just a little bit off, and you can't just like fudge that sort of thing on a test. It doesn't work out. So these are great. The reason why they're not great is because everyone else in my class already learned this, but I didn't because I took the prereq online. Fun times. So, where were we? Yes. A times log B, and then you have K. So, K is the horizontal stretch. IB, the International Baccalaureate Program, which is what I'm taking. They don't like saying compression. It's not a horizontal stretch or compression. It's just a horizontal stretch by a scale factor of whatever. So say you had 2 by a scale factor of 2. Because it directly affects the x, then it's the opposite of what you think it would be. So if you have scale factor 2 of x, then it would end up being x times 1/2. So all of the x values would be shifted inwards 1/2. Yeah. So all of the x values would be divided by 2. Then inside the bracket, you have x minus c. And the x is minus because, if it's a positive c value that goes in, then it will be negative inside the brackets, and if it's negative inside the brackets, then it goes to the right. If it's a negative c value going in, then it will be positive inside the brackets, and if it's positive inside the brackets, then it's going left. This is my left and my right. I'm not sure if this is gonna flip correctly when I upload this, so if I'm gesturing this way, it's my left, right. Outside of the brackets, you have plus d, and d affects the y value. So it's the vertical translation. C is a horizontal translation, K is a horizontal stretch, and A, which I forgot to talk about, is a vertical stretch. So if D is positive, then it goes up. If D is negative, it goes down. For A comes before the log. Because of log rules, which I should talk about, and I will talk about, that can also be written as x to the a. So you got log b, x to the a. Right? I'm gonna sit down. Log rules. So, say you have log, I'm gonna just assume that these are base 10. Log base 10, x to the a. That can also be written as a log x. So if you had log base x to the 2, x squared, the 2 would go to the front, so it would be 2 log x. Pretty neat, pretty fun. The next one, it's interesting. So say you have log base 3 to the, I'm trying to think of a value that's not, that wouldn't work for 3. Log 3 100. There's nothing that you can raise 3 to get 100. So you could let the 3 fall through the cracks. And what I mean by that is you would have log 100 over log 3. So it just ends up becoming a fraction. And while I don't like fractions as much as the next person, it's a lot easier to work with it like that than to try and figure out some weird equation. Yeah. Another rule, say you have log base 10 100x. That can also be written as log 100 plus log x, because the 100 and the x can be split up into two different equations with a plus sign in the middle. This can also work the opposite way. Say you have log 7 plus log x. You can squish them together so that they are log 7x. Pretty fun. And the last thing that you can do with logs is, say you have log and then, like, in brackets 3 over 7. You can separate that out too, yay, separating stuff, into log 3 minus log 7. Yeah, that is everything that I know about logs. Thanks for watching, I guess.